up, everybody? My name is Shoria Bansal, one of the coders on Fireteam. After finally setting up Android Studio and linking the FTC libraries, we can get down to coding. Today, we will begin by creating what's known as a hardware map, which allows us to use any of the devices connected to the Rev Expansion Hub or the Rev Control Hub in our code. Let's get started. You first want to open Android Studio into the folder that we imported in the previous video. In my case, it is Skystone, but this will be the folder where we stored all of our FTC libraries. To double check you have imported it correctly, look on the left pane and make sure you have one folder called FTC Robot Controller and another called Team Code. FTC Robot Controller is the folder first gave us with code samples. This includes different external samples to show how to use certain features such as the VuMarks feature to position your robot on the field, and TensorFlow, which allows you to detect objects. It also includes a few internal samples, which are just really basic internal mechanisms that you might need. All the code that we write is going to be stored under team code in the Java folder under org.firstinspires.ftc.teamcode. Any folder in this package will be pushed onto the robot. Once we're at this directory, we can begin creating our hardware map. There are two ways to create a hardware map. One is simpler, the other is more complicated. We will begin by creating the simpler version. In a later video, we can go over the more complicated version. To create it, click on the directory, right-click, click New, click Java class, and we now can give the Java class a name. I will call it hardware map. Make sure you have upper camel case, as that is the convention in Java, and click enter. This will, you can add this file to Git. If you want, click the remember button as well. Now this will be added to the Git repository that we made, which we connected to our cloud repository. And it'll put some code in there for us to begin. It'll have package, which tells Java to look in this folder, and it'll have public class. That is what every Java code begins with to identify where all the code is stored. Now that the class has been created, we can begin writing our code. First, you might notice a pop-up on the bottom right that says update your Android Gradle plugin. At all costs, do not update your Gradle plugin. FTC makes sure to ship their libraries with the correct plugin, and updating that will break your code. This has been a very big issue for me in the past and has made us spend countless hours trying to figure out where we went wrong. Updating it will not give you any benefit and will only hurt you, so click the X. Now that that disclaimer is out of the way, we can begin writing our code. The code that I will write is going to be very general, so you can extrapolate it based on your needs. However, you will probably have a very different hardware map compared to me because of the fact that you will have different hardware connected to your Rev hub. I will create a template with 4 motors and a servo. You will probably have more or less motors, more or less servos, and might even have a gyro. So that depends on what you have on your robot. The first thing that we want to do in our hardware map is create variables to store the different types of data we use. The first thing I'm going to do is create motors. The double backslash means a comment in Java. We will use the public keyword to determine that we want anyone to be able to access this. This will just make it really easy to use these variables that we make. The type for motors is DC motor. If you click enter, Android Studio will automatically import the correct directory for us, and then we have to give it a name. We'll make one for each corner on our robot: front right, front left, back right, back left. So do the same thing with a different name. And now that we have created these DC motors, we will initiate them later. I have an auto alignment plugin which allows me to easily align these. We'll go over that in our personalization section. This just makes the code look cleaner. Now we want to create a servo. I'll make a comment called create servo. Creating a servo is very similar to creating a DC motor. You just type in public, and instead of DC motor, you type in servo. You can click enter here, which will automatically import it, or hover over the word servo and click alt enter, which will also import it for you. Just depends on what you prefer. Then you give it a name. I will give this the name random servo. You can call it what you want depending on its usage. And there we have created the variables that we are going to use through this tutorial. Now that we've initiated the servo, we will need two what I call additional variables. We are done initiating the hardware variables. These two variables will allow us to use the hardware. First, we need a hardware map. You'll see in the list of options for hardware map, there are two. One is the team code hardware map, which is the one we're in right now. We don't want that. And the other is com.qualcomm.robotcore.hardware. This is the one we want to use. So double click that and you'll get a list, a really long name. That is because we called this hardware map. If you want a shorter name, you can type Shift F6 on this name, rename this to hardware, and use this as just hardware map. That is completely up to you. I will do this so that the code is easier for people to read. Now that I created a hardware map, I have to give it a name. I will give it hardware map equals null. Notice that I did not use the public keyword on hardware map. Using public can cause errors in the future, so we should refrain from doing that. I'll also add the comment here, additional variables. After hardware map, we need one more variable, and that is called elapsed time. This is going to be the only variable that we create up here. Public elapsed time, and we give it a name. I'll give it runtime equals new elapsed time, and you don't put any arguments or anything in this parentheses. Now that we have done this, we are done creating every variable that we need in this shell. Remember to keep in mind that you might have more motors, more servos, less of them as well, or even other hardware. Let me just align this and there. Now next, we're going to do what's called create a constructor, which is how we can use everything that we've made in this shell in another class, like where we create our teleop or autonomous codes. To create the constructor, all we need to do is use the public keyword and use the name of this class. If you switched the name to hardware, keep using hardware. If you did not, change this hardware to hardware map. You have two empty, you don't want empty brackets. You want to have in the bracket hardware map. And if you had the very long hardware map up here, copy and paste that, com.qualcomm, and give it a name. I'll call this HW map. And we created the constructor. What we're also going to do is create another method. We're going to call this a private method, so make sure you use the private method void, which does nothing, which means it doesn't return anything, but we can make a few changes and initialize things. And we're going to give it a name, initialize. In the parentheses, we're going to put in variables and arguments, hardware map, HW map again, and we created it. So what we're going to do in the constructor again, we're going to use initialize HW map. This allows us to easily, oh, I misspelled. This should be hardware map, sorry about that. This will allow us to easily organize our code. Inside initialize, what we want to do is actually start initializing the code. So we're going to do something. It's called reinitializing it. So we're going to use the hardware map that we declared up here. Hardware map equals HW map. This is just going to make our code a little cleaner and allow it to be a lot more universal. In case we made any errors, it'll be easier to identify. At this point, we want to start initializing our motors. So first, we select one motor at a time. We'll start with front right motor equals, then HardwareMap.get. And in get, we first need to select the type of class it is. It is a DC motor, so we're going to type DC motor dot class, comma, and then we have to put the name of the device. This all depends on how you initialize the device on your phone. When you create an initialization on your phone, you give each device a name and its port. This uses the name to connect to the device. So if you called the device front right motor on your phone, you use front right motor here. Make sure the spelling and capitalization is exactly as it appeared on your phone. This will make sure that you will properly connect to it. We will do the same with front left motor equals hardwaremap.get dcmotor.class front left motor. This all depends on what you called it again with the phones, so it might be slightly different. Then back right motor equals hardwaremap.get dcmotor.class back right motor, and back left motor equals hardwaremap.get dcmotor.class back left motor. Now that we have initialized these variables, we can go and move on to initializing the servo. Let me just align this just to make it look a little cleaner. Now for the servo, we do something very similar. But instead of using dcmotor.class, we use servo.class. So we select the name of the servo, random servo equals hardwaremap.get servo.class random servo. Again, make sure the name in the string is the same spelling and capitalization as is in your code in the phone, because otherwise you won't be able to connect. I'll leave a few comments. Connect motor and then connect servo up here. This is just so that when I go back to the code, I can easily identify it. Now this next part depends on the position of your robot and the motors that you are using. You will have to do a little trial and error in this. So we will figure out the correct values after we write our teleop, which is in a later video. So at this point, you can just use the standard that I am using. This will probably change at the time of writing the teleop though. We're going to set up motor direction. Because the motors are in different positions, one facing to the right, one facing to the left, the forward for one will not be the forward for the other. So this setup will make sure that the forwards are the same. So we begin front right motor dot set direction. I will use DC motor dot direction dot forward, all caps forward. We might have to change this depending on the motors we use. Then same thing with front left motor, set direction. And since this is in the opposite side, this time it's going to be DC motor dot direction dot reverse. We do the same thing for back right motor as for front right motor, and the same thing for back left motor as front left motor. The reason for this is the right or left side determines which direction is forward or reverse for the motors, not the front or back. Now that we've done this, we just want to set all of the motors to stop moving, and we want to set the zero power behavior. Zero power behavior is something that you tell the motors to do when you provide the power of 0. There's a few options. We are going to use the stop option, which makes the motors stop itself from moving at all. Other options include free spinning and others. We don't want to do that. We're going to set it to stop. So set zero power behavior in a comment. Front right motor dot set zero power behavior dot break. Zero power behavior dot break. Float means you let it move, but you don't stop it. Break sets it to stop moving at all. You might have a different necessity, so you might have to change it depending on what your motor's role is. But if it's a standard movement motor, you want to keep it at break. This will stop other robots from pushing you around. Back right motor dot set zero power behavior break. Back left motor dot set zero power behavior break. And this leads on to the very last part. Set motors to use no power. This sets each of the motors to a power of 0 so that we can stop them from moving once we initialize the robot. So front right motor dot set power 0. Front left motor dot set power 0. Front back right motor power 0. And the same thing for back left motor. And once we have done this, we are almost done. There's one more thing we need to do. We should do this before we set after we set the motor direction. This is optional, but I highly recommend it. So what you want to do is set the mode for the robot. Set motor mode. This depends and uses exactly how you're going to use the robot and motor to move. For example, if you've set up the motor to use encoders, this will allow you to track its movement, and that is what we're going to set it at this point. If you haven't gotten to the stage of using encoders, do not worry. You will just set the mode, so front right motor dot set mode, and you will choose the mode. We have to do run mode dot. There's a few. Run using encoders, run without encoders. If you don't use encoders, do run without encoders, stop and reset encoder, and run to position. We will first do stop and reset encoder, and then run using encoders. Stop and reset encoder resets the encoder so you can set it at 0. Front left motor dot set mode, stop and reset. Back right motor dot set mode, stop and reset. Back left motor dot set mode, stop and reset. Then you do the same thing, front right motor dot set mode, run using encoders. If you are not using encoders, then don't worry about the first section. Only use that and type that if you are using encoders. After we do this, we are done making our basic hardware map. So let's just finish this off. And now that we've done this, we have created our very first hardware map. I accidentally imported that. And here we can now we can start using this to use any simple movement, and we can start writing actual movement code for our robot. I hope this video helped. If it did, please leave a like and subscribe to our channel. We are releasing new videos as soon as we can. If you want to see this code, this will be uploaded to the GitHub page, which is in the comments, in the description. I can't wait to see you in the next video. Have a great day.